Hello again, this is Dave, also known as the Old Buick Guy, and today we're going to do part 2 of the discussion on CDI versus standard ignition systems. So last time I just basically gave an overview of the project. Today I'm going to delve a little bit more into the historical aspect of ignitions systems on these early automobiles and early gasoline engines. So going back to the very beginning, when they first started to develop the gasoline engines, of course they had the analog of the steam engines, in other words the cylinder and the piston, and the valves, so they knew how to do all that. What they weren't sure about at first was, well, how do we get the gasoline air mixture ignited inside the cylinder? One of the very early things they tried was a hot tube. This basically was a tube that went in through the side of the cylinder wall, was heated outside by either a gasoline flame or something similar, and the tube would glow red hot, and then when the mixture was on now we're talking 4-cycle, when it was on the compression phase, it would ignite the mixture and it would go. Now you had no timing or anything like that. It just, once the mixture hit the right point, it would ignite. Of course, back in those days, with the gasolines and the fuels that they had, and the machining tolerances, etc., it probably worked adequately. You weren't going to get anything like a smooth idle anyway. But the problem with that, of course, was that you had to keep that tube hot, and you're running around in an automobile with, trying to keep a flame going on that tube. That isn't going to work too well. So that didn't last too long. Very shortly after that, they got into what's called the jump spark method. So how are we going to do that? Okay, well, so we're going to have a series of slides here, and I'll discuss what you're seeing. So on the first one, you basically have a set of essentially points inside the cylinder where the piston has an actuator on it, and it comes up and essentially it breaks the connection. Now you can see that you've got just a battery connected in series with a coil. And this coil has, fairly high inductance, probably got an iron core. And so what happens, of course, is that once you break, there's no condenser or anything in there. Once you break the points, you're going to get a pretty small spark. And it probably was adequate at the time. The advantage of this kind of method is now we actually can get into some engine timing here where it's going to deploy the spark at the right time. But of course you had to have a battery to do this, and these were dry batteries now we're talking back then in those days. So, and then of course the progress went on, and you had similar kind of thing. You still had the breaker points inside the cylinder, but you had a cam on the outside that was actually actuating. It twisted the one rod in the center and opened up the points. So it was a little bit of an improvement over the other method. Still worked though the same way. You had a dry battery. Again, more progress. The same kind of thing, the next slide, except instead of a battery, now we had a magneto. So you have a large permanent magnet acting as the field, and you tied off the engine power somehow via a pulley or something similar. You had a wound coil, as you can see, that basically, just from the turning action of the coil through Faraday's law, which we'll get into later, you were generating a small current, which then went up through the coil and was opened up as before. So this is now getting a little bit better. Of course, one of the problems with the magneto, and this was one of the reasons why they didn't persist, is that when you're trying to start the car, you don't have much turning action on the magneto. There's not much energy out of it. And that, of course, was a big failing. So they got more complex. Time went on. Now we're talking about, getting towards the late, late 1900s. So they started being a little more complex. And in the next slide, you can see that you actually have something similar to the circuit of an ignition coil on the side, wherein the magneto excites the primary, But there is still the breaker point. So the field collapses within the ignition coil, as in the Kettering system, as we'll explain. And then you had the secondary winding, which was a step up, and you had more voltage over to the plug. Still a little bit complicated because you had a wound rotor on the magneto, and then of course you had to deal with these brushes with the low tension. So then the next phase of this was basically, this next one is actually when they went to a permanent magnet on the magneto itself, and to heck with a wound rotor. So you had a permanent magnet, and you essentially moved the coils up to the armature of the magneto. And this probably was the final, it is the final form. Modern magnetos essentially work the same way. As you can see on the slide, there's you still have the points, but now you've got a condenser in there. You have some kind of a rotor which routes the spark to the proper spark plug, and that is essentially the way that modern magnetos, like an aircraft today, work. Again, they didn't work bad. Magnetos were used in U.S. cars, made by Bosch and other companies up to almost 1920, maybe even beyond. But you still had the problem of when you went to start the car, you had lesser spark, and that was especially if you're trying to crank things by hand, that's a problem. So just to give you an idea of one ignition system that was used in a lot of cars, and this is the one used in the Model T. Now this used a magneto, but in a different way than I've described before. And of course this was put into so many cars, millions and millions, that it's worth discussing briefly. There was this kind of system used, either you could go with a magneto or with a battery. So when you went to start the car, you could flip it to battery. Again, we're still talking about dry cells here, nothing, no lead acid batteries yet. The coil that was used, you see there from the diagram, there's a coil on each spark plug, which is kind of looking forward to today, where you have coil on plug. But of course back then, with the manufacturing and stuff, that actually created as many problems as it solved. So here is a Model T spark plug coil, as is discussed here. You can see, coming closer, that there's these interrupter points here. What happens when a battery's hooked up, and I'll show you that, is that this acts as a vibrator. So when the current pulls it in, then it breaks the circuit in the primary, which is acting as a solenoid basically, and then it comes back, and then it reconnects the circuit, and then it pulls back again, and it vibrates, similar to an old-fashioned doorbell or a buzzer. You may have played around with those. But the difference here is that there is a secondary wound on top of the primary, just like in an ignition coil, and using the same principle of the collapsing magnetic field, which would then induce the EMF or voltage, which then gets stepped up by the secondary, which then goes out to the spark plugs as the high tension. Now, going back to the diagram, the way they worked it, the way Ford worked it, was the magneto in this case was actually on the flywheel, and he had a whole bunch of coils that were stationary and then actual permanent magnets mounted on the flywheel itself. And they had to be set so they rotated very close, so this was a setting that had to be adjusted. The magneto, when it was running, would kick out, when the engine was actually running, would kick out somewhere around 40 volts or thereabouts, and this was alternating current because there was no commutator. So it was AC, plus and minus polarity. And the way that it worked is when the engine was running and you switched to magneto, the 40 volts would go to the primaries of the coils. And since it was already AC, you didn't need the interrupters. It would just automatically get stepped up to the high tension. And when the timer essentially grounded the the coil so that it could, you know, transmit the energy over to the plugs, and then the plug would fire. So there was timing on it, and of course in the Model T there was a retard and advanced spark control. So the timer in effect just grounded the particular coil that made it operate. Now if you're on battery, then when you grounded it, then the vibrator would start to vibrate. So, and you had basically continuous spark until it was ungrounded, as long as the vibrator would vibrate or the magneto was going through it. Now one of the problems with this system, besides the fact that you had to have 4 of these coils, is that if they weren't adjusted similarly, you could get different types of spark, or different amplitudes of spark rather, for different cylinders, and it wouldn't idle very well. So that was one issue with these things. Plus, if you you know, some of the later aftermarket ones weren't made to as good tolerances, and there were some problems with them. So you know, it was expensive, because now you had to have 4 coils. So basically, it was a good cheap system at the time, though. When Ford came up with this in what, 1908, it was multiply the production by the millions of cars, and he actually did all right with this. And then there's a lot of these coils still floating around today. So anyway, that was the kind of the state of the art. Now what I'm going to do is do a quick demo of this Model T coil, so you can actually see it fire and get some high tension spark. So here's a Model T spark coil, and like I said, there are millions of these things. So you can see this one is if you can see the writing, is a Ford. So it's one of the ones that Ford itself made rather than one of the aftermarkets. I'm going to hook it up. The positive terminal goes on the back. And the negative terminal is here. Now when I connect this, you'll see this vibrator start to vibrate. And there it goes. You can kind of see the light there from the spark as the energy pulls it in, then it breaks the contact and the spring pulls it back. Then the whole thing repeats. Frequency generally being regulated by the length of the arm and spring tension. And of course that creates the reconstituting and then collapsing current in there, which then induces the voltage into the secondary winding from the primary, which then produces the high tension spark, which we'll look at now. I'm going to use these so that I don't buzz myself. Too bad anyway. There it is. And it's about a 1/4 inch spark. And you can see that it's continuous. I mean, as the interrupter or the vibrator points keep going, it just keeps creating the high tension. So like I said, as long as that commutator had this thing switched on, it would just produce. So it was kind of an early multiple spark device, I guess you'd say. So anyway, like I said, there's millions of these things made. Kids used to get them all the time and do experiments with them. They were pennies on the dollar, I'm sure, at least up to the 50s, maybe even into the 60s, to buy these things. Kids also used them back in the early days of amateur radio to generate spark, which of course back then it was spark transmitters that were being used. Of course not much of a spark, but you know, with these you could maybe work a few blocks or something. And so that was something that somebody could, you know, use to get on the air without spending too much money. Well, that was interesting. So next time, just keep this one short. Next time we'll get into the Kettering design and why that was superior and how it ended up in in so many automobiles and why it lasted as long as it did. So thanks a lot for looking. See you next time. As a friend of mine says, always build from the heart, and I'll see you in the bar.